Hello everyone, and welcome to the Mat 211 review on Maxima and Minima. My name is Julia and I work for the tutoring centers at ASU. So for today's problem, we're going to look at finding and classifying the critical points of the following function. That's f of xy equals quantity y minus 1 times x squared minus 2y squared. So to start this problem, it's going to be helpful to first compute all of the first and second order partial derivatives. So we're not going to go through this process in great detail here, but if you are unfamiliar with this process, then please see our videos on partial derivatives. That'll give you more information on how to take first and second order partial derivatives. So for our problem here, we have f of x, so I'm just going to kind of write these down. That's going to equal 2 times y minus 1 x. So we can see that because this term will go away because we're looking at x, and we'll just be taking the partial derivative of this guy. This guy will be treated as a constant. So let me unscribble here. For our f of y, we have x squared minus 4y. Let me write this a little more neatly. There we go. That's a little easier to read. And then for our second order partial derivatives, which would just be the partial derivatives of these two, we have f of xx equals 2, oops, that's not right. Here we go. We have 2 times y minus 1. And then for our partial derivative fyy, we have just -4. And lastly, for our partial derivative fxy, which is in this case going to equal fyx, this is just going to be 2x. All right, so now that we have all of those, we're going to find our critical points by setting both f of x and f of y equal to 0. So we're starting with the first order partial derivatives here. So this gives us f of x equals 2 times y minus 1 times x equals 0. And our f of y, make that y a little smaller, there we go. F of y equals x squared minus 4y equals 0. So we can rewrite this as a system. So we're thinking about our systems here. This is a system of equations that is 2, and let's just go ahead and multiply this out for ease here. 2yx minus 2x equals 0. Yep. And then x squared minus 4y equals 0. So we need to go through and solve this. So let's start by looking at the first equation here. So we have 2, and actually it might be easier just to keep this in terms of 2y minus 1x equals 0 here, simply because we're going to go ahead and factor it anyways. So we can just divide out this 2 here, divide it from both sides, and that gives us y minus 1 times x equals 0. And so from this, we know that either we have to have y minus 1 equals 0 or x equals 0. And we can solve this. This is just y equals 1. So we have a y equals 1 or x equals 0. Okay? So let's look at this first case here where x equals 0. So we'll just write this up here. X equals 0, put him in a little box to know we're talking about this. So we're going to use our second equation now because we started with our first equation over here. So we're going to use our second equation to determine what the corresponding value for y would be. So we have x squared, so 0 squared, minus 4y equals 0. So that just goes away. So we have minus 4y equals 0. We can divide out the minus 4. That just gives us y equals 0. So what this tells us, and we'll write up our critical points up here. What this tells us is that the point 0, 0 is a critical point. So now let's look at our second case where y equals 1. We'll just draw a line here. So in y equals 1, we're going to again use the second equation. So that gives us x squared minus 4 times 1 for our y equals 0. So this is just 4. So we have x squared minus 4 equals 0. So we can add a 4 to both sides. Just to get that over to the other side. That gives us x squared equals 4. And so therefore, if we take the square root of this, now remember that when we take the square root, we both have -2 times -2 equals 4, and 2 times 2 equals 4. So we need to make sure that we reflect that in our answer. So we have x equals plus or minus 2. Okay? So what that tells us is that for y equals 1, we either have -2, 1 as a critical point, and we also have 2, 1 as a critical point. So that's either value of x here, plus or minus 2, is paired with y equals 1. Great, so we have our 3 critical points, and we need to classify these now. So I'm just going to go through and erase a little bit here just to make myself some space. Get rid of that. We'll just leave all this over here for now. We can probably get rid of that too. So in order to classify these points, we need to compute this function d of xy. We just call it d here. That's just a term for it. Equals our fxx, our second order partial derivative f of xx, times fyy minus f of xy squared. Okay? So this is going to give us some value, and for any point that we put in, xy point that we put into it, it's going to give us a positive value or a negative value or equals 0. So when we have d of xy for some point xy, when that is less than 0 at a point, this means we have a saddle point. If we have d of xy, is greater than 0, then we have 2 cases. If we have just our fxx, so just our partial derivative here, if that is less than 0, then we have a relative max. If instead this f of xx is greater than 0, we have a relative min. And lastly, every once in a while you'll come across d of xy equals 0. This means that we cannot determine whether this critical point, is a relative max, a relative min, a saddle point, or something else from just this mathematical method. We'll have to graph it or use some other tools in order to figure that out. So we'll just say that this is undetermined from this method. All right. So how do we use this with respect to our particular problem here? Well, we're going to start by calculating this, and then we're going to substitute each of our 3 critical points in to calculate its value. So let's start by calculating this. This is going to be f of xx, which is our 2y minus 1 from over here, times f of yy, which is negative 4. And we have minus our f of xy squared. So we have f of xy is 2x here. And we're going to square that. So if we work out our math on this, when we go through and simplify this, we should get negative 8y plus 8 minus 4x squared. Okay, so that is our d of xy. So now we want to evaluate that at each of these 3 critical points. So at 0, 0, we're going to have negative 8 times 0 plus 8 minus 4, 0 squared. And that's just going to equal 8. Since that is greater than 0, we need to look at whether our f of x at this point is greater than or less than or equal to 0. So if we have our f of x here, so our f of x, remember this was 2y minus 1. So we get 2 times y is 0 minus 1. And that is equal to, just write this in here so it's clear. That is going to be equal to negative 2. And that is, of course, less than 0. So we see here that this first point is going to be a relative max. So we'll just write max up here to make it clear. All right. So let's evaluate our second point. I'm going to just erase this here. And our second point is going to be, we're going to use this negative 2, 1 here. So negative 2, 1. And we'll do the same process here. So we have negative 8 times 1 plus 8 minus 4 times negative 2 squared. And if we go through and work that out, that's going to equal negative 16, which is less than 0. So this is a saddle point right away. And we see that because any time that our d of xy here is less than 0, it means that we're at a saddle point. So lastly, let's look at our point 2, 1. Boop, boop. And that's going to give us negative 8 times 1 plus 8 minus 4 times 2 squared. So this is going to actually equal the same thing. It's going to equal negative 16 again, since the only difference really is this, and it gets squared, so it turns into a positive. So again, less than 0. So we know this point is also a saddle point. So in conclusion, we have that the point 0, 0, this is a relative max. And then our points negative 2, 1 and 2, 1 are saddle points. And that's it. That's all she wrote. So there we go. Clear this, advance to our next screen here. So just before I go, I wanted to remind you all that if you're looking for any additional tutoring or academic support services at ASU, you can visit this link, tutoring.asu.edu, to access all of our various resources. If you are looking for tutoring on a specific course, you can use our tutor search function, which you can find at this full link here, and that'll allow you to search for a specific course and find which resources we have at which times. So thanks so much, and have a good rest of your day.